The next couple sections that we're going to look at involve simplifying expressions. The first thing we're going to look at is expressions and the distributive property. This comes from sections 1.4 through 1.8. In order to complete this section, you do need to know your rules for multiplying integers. Upon completing this presentation, you will be able to multiply an expression by a constant using the distributive property. So before we begin with simplifying expressions, let's go ahead and talk about a couple more vocabulary terms that we have. The first one that we have is terms. Terms are constants, variables, or the product of constants and variables. Those variables may be raised to exponents. Another way to think about terms is they are separated by addition and subtraction. Our second vocabulary word that we have is coefficient. This is the number part of a term. We have a constant term. This is a term that consists of just a number. And then one of the things that we're going to be focusing on is like terms. Like terms, these are terms that have the same variables. Those variables have to be raised to the same powers. Like terms, another way to think about this is everything but the coefficient must be exactly the same. We've used the word like before. If you remember, we talked about like fractions. And when we start working with like terms, we're going to see that it's going to be similar to when we worked with like fractions. We'll see that in the next presentation. So let's go ahead and check our understanding of these vocabulary words by looking at just a quick example. We want to analyze the expression and identify certain things. So the first question that we have is how many terms are in the algebraic expression? This expression has a total of 3 terms. We have 4x, 7, and 5x. These are the things that are separated by the addition and subtraction. So we have a total of 3 terms. We want to know what is the coefficient of the first term. The coefficient of the first term is 4. This is the number part of the first term. What is the constant term? Constant term, remember, means there is no variables. And so our constant term is going to be 7. And finally, what are the like terms? Which ones have everything but the coefficient being the same? Well, for that we have our 4x and our 5x. These are considered our like terms. So hopefully that makes a little bit more sense and that we are good with these terms or these vocabulary words. We will be using these throughout the semester whenever we talk about simplifying expressions. So we've talked about some of the properties of real numbers, and these properties still apply to algebraic expressions. In the first chapter, we talked about the commutative property. Remember that the commutative property states that order does not matter. You can add numbers in any order, you can multiply numbers in any order, and now we can add and multiply terms in any order. We also have the associative property. The associative property tells us that grouping does not matter. So just like with our numbers, we can add in any order, we can add in any grouping, we can multiply in any grouping. Similarly, with expressions, we can combine terms through adding and multiplying in any grouping that we want. The final property that we have that is mostly used when we get into the algebra section is the distributive property. The distributive property, if you think back to the first day of class, I distributed the syllabus, which means that everybody got one. So the distributive property acts in that same way. It is a combination of operations, multiplication, and addition and or subtraction. And what we do is we basically multiply everything inside the parentheses by whatever is outside the parentheses. Other forms of this, you can see you can have a subtraction, and the subtraction sign will basically just carry over. The second one, this one you won't see as much, but it is possible. You can have your binomial or your thing inside the parentheses on the left side and then the constant on the outside on the right side. And again, it's the same thing. We just want to multiply b times a, c times a. If you don't like it this way, just remember that because of our commutative property, no one says that the a has to go on the right side. You can always reverse this and make this into a times b plus c using our multiplication rule of the commutative property. The last one that you can have is you can have more than two terms inside the parentheses. And just like the other ones, again, we want to multiply everything inside the parentheses by whatever is outside the parentheses. So you get AB plus AC plus AD. So we're going to play around with the distributive property to start off with and see what we can do with this. This is one that the distributive property is extremely important when we talk about simplifying expressions. When we talked about order of operations, we always talked about simplify inside the parentheses before you multiply. But when we start talking about algebraic expressions, that may not be possible. And so we will want to be able to use the distributive property. So let's look at the following examples and see what we can do. If we start with example A, we have 6 times x plus 4 inside parentheses. So I'm going to start by multiplying everything by 6. We get 6 times x equals 6x. We get plus 6 times 4. If you want to do this step mentally, that's fine. You can go ahead and just say this is 6x plus 24. You do not need to write out this step here. It's up to you. If you do get stuck or confused, it's always a good idea to write out as much as possible. All right, let's look at example B. Example B, we have 5 times 3y plus 7. So again, I want to multiply everything inside the parentheses by 5. If we do this, we get 5 times 3y and plus 5 times 7. If we simplify each one of these terms, we get 5 times 3y is 15y, and 5 times 7 is equal to 35. And, sorry, this should be a plus sign. We're not to the equals. we get 15y plus 35. Okay, let's look at example C. Again, I want to multiply everything by 5. I'm going to go ahead and just jump to the answer now. If you still need to kind of write it out step by step, that's fine. But I'm going to go ahead and multiply 5 times 4y. We get 5 times 4 is 20. We keep the y. We get 5 times minus 3 is minus 15. And you're done. For example D, this is one where we have more than 2 terms inside the parentheses. But again, remember, it's just the same thing. We just want to multiply everything inside the parentheses by 4. So if we do this, we get 4 times x is 4x. 4 times 10 is plus 40. And 4 times 3y is equal to plus 12y. And we're done at that step. Okay, so now let's go ahead and bring in some that are just a little bit more complicated. Let's look at example E. So example E is still kind of a basic one. Again, we want to multiply everything inside parentheses by whatever is outside. So I'm going to multiply 9 times x gives me 9x. I'm going to write the 9 on the left just because that's more of a standard notation, is always writing the coefficient in front of the variable. And then I'm going to multiply 9 times 7, and we get 63. So our final answer is 9x plus 63. Okay, let's look at example F. We have negative 2 times 3x. So my question to you is, do I multiply 3 times negative 2 and x times negative 2? Is this really a distribution problem? And the answer to that is no, this is not a distribution problem. The reason is because notice that inside the parentheses all we have is multiplication. We don't have any adding or subtracting. And so this is technically not a distribution problem since we do not have multiple terms inside the parentheses. There's just one term. So for this, all we're going to do is multiply negative 2 times 3, we get negative 6, and we keep the x. And we're done. Okay, if we go ahead and look at example G now, we have negative 3 times 2x minus 5 inside parentheses. We want to distribute, and we also want to make sure that we remember to distribute the negative that is with the 3 as well. We're going to multiply everything by negative 3. So if we do this, we get negative 3 times 2x is negative 6x. And if we multiply negative 3 times negative 5, we should get plus 15. Make sure that you take these two negatives and make them into a positive. Our final example, H, we have minus 3y plus 8. We need to distribute the negative. If you're not comfortable with multiplying by just a negative, note that we do have implied here a 1. This is minus 1 times 3y plus 8. And so if you want to multiply everything by negative 1, that's essentially what we are doing. So if we do this, we get minus 3y minus 8. Now, these last two examples, G and H, you want to make sure that you are very careful if you see these on homework and on quizzes and on tests. I like the problems involving distributing a negative because quite often people do miss this problem. So make sure that you remember this rule in terms of not only distributing the number, but distributing the sign as well. So that takes care of our distribution property. So now please go ahead and try the following problems on your own. Bring your answers to class, as well as any questions that you might have.